Today's contents of discussion: the modulus of a complex number, principal argument of a complex number, and what are the properties of modulus and conjugate of complex numbers. Modulus is very easy to understand. See here, if P is a point in a two-dimensional coordinate plane, then distance d is equal to root over x square plus y square, which is a positive quantity. Similarly, if z is equal to x plus iota y is a complex number, then the modulus of z is given by modulus z is equal to root over x square plus y square. In the Argon diagram, plotted a complex number point here minus x minus iota y. For example, the distance of this point from the origin will be given by minus x whole square plus minus y whole square. Real part of the complex number whole square plus imaginary part of the complex number. So this implies that we have understood. Now we are going to the concept of principal argument. Okay, suppose this is a point x plus iota y in the first quadrant, okay, and here in the third quadrant also another one. So this is making an angle of theta with the positive direction of the real axis. Here the modulus vector of this point is making an angle theta, and this same thing, this one can be denoted like that also, minus theta, because we are measuring from the clockwise direction, and here we are measuring from the anti-clockwise direction. So okay, suppose this value is, that means an acute angle, okay. So here 180 degree plus 30 degree is equal to 210 degree, and in this direction if we come, then this will be minus 150 degree. Okay, in any manner we describe the angle, but the position is same, actually fixed position. Okay, so there are two ways to describe a theta of the complex numbers. Okay, now what is principal argument? Principal argument is given by arg of z is equal to theta. A student can write in this manner also or in this manner also, that is theta lies in this interval, okay, greater than minus pi, equal to or less than pi. This is followed in the NCERT book. This value of theta in this range is called principal argument of a complex number. Take a problem on modulus. If z1 is equal to 2 minus iota and z2 is equal to 1 plus iota, then find the modulus of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. Solution: z1 plus z2 plus 1 by z1 minus z2 plus 1. Now we are putting the given values. z1 is equal to 2 minus iota and plus z2 is equal to 1 plus iota. After that 1 added. Okay, 2 minus iota minus 1 plus iota plus 1. Here 2 minus iota plus iota will be cancelled, and here again 1 plus 1, 2. And here 2 and minus iota, then minus 1 minus iota plus 1. So 1 will be cancelled and remaining 2 minus 2 iota. Plus of this 2 to 4 into 2 plus 2 iota divided by 2 minus 2 iota into 2 plus 2 iota equal to 1 plus iota by 1 minus iota square. Understand? A minus b into a plus b format. So it is a square minus b square. Okay, equal to 2 into 1 plus iota by 1 minus of minus 1. 2 into 1 plus iota, and here minus minus plus 1, so 2. Okay, so these 2 to cancel, equal to 1 plus iota root over 1 square plus 1 square equal to root 2. Now we shall discuss the properties of modulus and conjugate of complex numbers. Taking an understanding example like this, z1 is equal to 5 plus 3 iota and z2 is equal to 3 minus 7 iota. Then the conjugate of the sum of the two complex numbers is equal to 5 plus 3, real part is 8 and 3 iota minus 7 iota, remaining minus 4 iota of this conjugate. Okay, so equal to what it will be? Change the imaginary part sign. So equal to 8 plus 4 iota. Now let us see individually. Conjugate of z1 plus conjugate of z2 is equal to 5 plus 3 iota plus 3 minus 7 iota conjugate. Okay, equal to, so conjugate of 5 plus 3 iota will be 5 minus 3 iota by changing the real part sign. Okay, and here plus 3 plus 7 iota equal to, we get again 5 plus 3 8 and imaginary parts here minus 3 iota plus 7 iota, remaining plus 4 iota. See here, please see the properties of the modulus and conjugate of complex numbers. Okay, so first group is for modulus and the second group for conjugate. Okay, by sign you can understand. See, if a complex number is given as z, then the complex number z into conjugate of the number is equal to modulus of the number square, and number 2, modulus of the product of two numbers z1 and z2 equal to the product of the separate moduli. Okay, and number 3, the modulus of the quotient of two numbers will be individually equal to the quotient of the individual moduli, provided z2 not is equal to 0. And number 4, another result that modulus of a given complex number will be equal to the modulus of the conjugate of this number, again equal to modulus of the negative of this number. Okay, and then for conjugate, the conjugate of a number, see inside the bracket z bar, you take the z is the number and then you take the conjugate, after that again take the conjugate, you will get the original number. And second is that, as we got here actually modulus, here in conjugate also multiply the two complex numbers z1 and z2 first and then take the conjugate, it will be seen that they are equal to the product of the individual conjugates. And here same way, here again inside the bracket you see z1 by z2, sorry, z1 by z2 and then conjugate, it will be equal to the conjugate of z1 divided by conjugate of z2 if z2 is not equal to 0. And one more result also, conjugate of the sum of the two complex numbers z1 and z2 will be equal to the sum of the individual conjugates.